Hello friends, myself Pramod Shahaji Patel, Assistant Professor in Department of Chemistry, lead Pushpa Devi Patil, Arts and Science College, Risoo. Today we are going to see from your syllabus, that is unit second from your syllabus, and from unit second there is a part A and B in unit second. Today we are going to start the part A from your syllabus, that is S block elements. You have very known in 11th and 12th you have learned the periodic table, periodic properties, and the S block, P block, D block, and F block elements. Okay, so here we are revise the S block elements. You know the periodic table, that is the groups, first A, second A, or we can say first group elements and second group elements. So these are the groups, or these are the S block elements, these two first and second group elements, that is the first A is the alkali metals and second A is the alkaline earth metals. First A is the alkali metals and second A is the alkaline earth metals, that is first group and second group elements: lithium, sodium, potassium, rubidium, cesium and francium. These are the first group element. Then beryllium, magnesium, calcium, strontium, barium and rhodium is the second group elements. So here is the introduction of the S block elements. So why these are called as the S block elements? Is the simple answer is the outermost electrons are present in the S subshell or S orbital. The elements are having a last electron which is present in S orbital. That's why these elements are called as the S block elements. Also, p orbital is completely filled. Okay, from the electronic configuration of these elements, the p orbital is completely filled or complete, and the unpaired electron or the outermost electron is present in s orbital. That's why this is s orbital, and it doesn't having a electron in its d orbital. Means in electronic configuration of these elements, they don't have the single electron in the d orbital. So these are the this is the introduction of s block elements. Now we have here comparatively study the first A and second A group elements and their different properties, or first A group or alkali metal and alkaline earth metal, that is second A, or where we can see first group elements and second group elements as comparatively, or we can say separately. So firstly we will discuss the first A group element or first group element, or nothing but we can see the alkali metals. So why these elements are called as the alkali metals? So here is the these elements are alkali metals since they readily dissolve in water to form soluble hydroxides which are strongly alkaline. Okay, this is the answer of the question, is why these elements are called as the alkali metals, because these elements are dissolved in the water and forms a hydroxides, and this solution is a alkaline. Alkalines means your basic solution, acidic and basic. So this is the basic or alkaline. So that's why these metals are called as the alkali metals. So we will discuss here the electronic configuration of these alkali metals or first A group elements. So here is in this table, here is the electronic configuration of first group elements or alkali metals. So here you can see in periodic table there is a hydrogen, but hydrogen is not comes under this group. Hydrogen is separate, so this group is started from the lithium. The symbol of lithium is Li, atomic number is 3, having a electronic configuration is 2 and 1, or here is the helium atom having a electronic configuration is 2s2, means completely filled s orbital, and this lithium having one unpaired electron in s orbital, that is the 2s1. So valence shell configuration is the 2s1. Then next one is the sodium symbol Na, atomic number 11, and the electronic configuration is Ne3s1 or 281, and so here is the valence shell configuration is 3s1. Then next one is the potassium, symbol is K, atomic number 19, 2881. Here first, then second and third, and the last one. These octets are complete and one are paired electron in the s orbital, that is Ar. These are the noble gases means these are having a complete or electron field at their, that's why they are the noble gases, and the valence shell configuration is 4s1. Then rubidium, Rb is the symbol, atomic number 37, and this is the electronic configuration 281881 or krypton 5s1. Valence shell configuration is 5s1. Then cesium, Cs, atomic number is 55. Then Xe6s1. So valence shell configuration is 6s1. Then francium is Rn7s1, and the valence shell electronic configuration is 7s1. So here is the question. The francium is the radioactive element, but it comes under in this group. Why? Because this francium is also having a 7s1, means last electron is in s orbital, so that's why this is comes under this category. Then next one is the ionization energy. What is meant by ionization energy? The minimum amount of energy required to remove the most loosely bound electron from an isolated gaseous atom of an element in its ground state to produce cation. So simply ionization energy means the most loosely electron from its outermost shell. To remove that electron, we have, or he is having some particular energy, and that energy is the ionization energy. Here is all compounds are having a loosely bound electrons, so here is the atomic radius of that particular element, and here is their first ionization energy. So lithium is having 1.52 angstrom radius, and this ionization energy, or this is indicated by IE, that is ionization energy, or IP, that is ionization potential, and it is measured in kilojoule per mole. Then next one is the oxidation state. So these alkali metals or first group elements are having a oxidation state of +1. These shows only +1 oxidation state. Why? Because they are having a only one outermost electron in their electronic configuration or their outermost shell, which is loosely bounded, only one, so they can easily uh, lose their one electron. That's why these shows only the +1 oxidation state. Then the reactivity, the alkali metals are highly reactive, okay, especially towards the electronegative elements like chlorine, fluorine, bromine, oxygen, etc., and which forms the your ionic compounds. You know very well the one example of ionic compound, or this example is KCl or NaCl, the salt of our daily life salt, which is a NaCl. Na from your alkali metal and Cl minus is the electronegative atom. So these are the more reactive towards the electronegative atom and forms the ionic compounds. The example is the NaCl, our daily life use salt. Okay, then their reactivity increases with increase in atomic number. When we go from top to bottom, their atomic numbers are increases, and it means their reactivity also increases. So that's why the one most example is the alkali metals are stored in kerosene. Why? Because uh, the atmospheric CO2 or O2 is reacted with the alkali metals and form the other compounds. So that's why these metals are stored in kerosene. You have seen in your laboratory the sodium Na is stored in kerosene, sodium metal. Okay, and the next point is the flame coloration. These compounds shows different colors in the flame, that is the Bunsen, on the Bunsen burner or the Bunsen flame. This lithium shows the deep red, then sodium shows the yellow, potassium shows the lilac, rubidium shows the bluish red color, and cesium shows the blue color. So these different elements shows the different color. So that's why these are used in the qualitative analysis, or is called as the flame test. This property is used to detect the presence of these metals in qualitative analysis and is known as the flame test. You have done these practicals in your 12th practical, the flame test, that is burner, sorry, Bunsen. On the Bunsen burner you have uh, doing this flame test. Thank you. We will see the next part in next lecture. Thank you.